class, if you finished the news vendor simulation in previous video, that will be great. Most of the things are the same for this video, except now the demand distribution is not normal distributed. The demand is a discrete distribution, which is described here. So there is some chance demand will be 100, then the demand can be 150 with chance of 20%, and so on and so forth. And we want to generate a demand following this distribution. And the discrete distribution is also widely used in practice, so we need to learn how to generate random demand like this. So as you remember in the previous class, we talked about how to generate random variable. So this is a time we should practice that. So to help you to understand, let me first write down. Let's first write down the cumulative probability, which is just it's cumulative, so it's the sum of all the previous probability. In this case, is this. In the first case, is sum of itself, and then we have to lock the first cell because we want to drag this. So if we write this formula and we drag all the way down, you get a cumulative probability. So in this, for the second cell, basically is the cumulative of the first one and the second one, because we lock the first one, so the first one will always be the same. As we drag through the second cell, will change corresponding, and I'll give you the cumulative. Let's look one more cell. So the cumulative sum is the first three is like this. Okay, and then the range of the chance will be in this case is from 0 to in this case is from 0 to 0.3. This is the range of the probability. In this case is 0.5 to 0.3 to 0.5. In this case is 0.5 to 0.8. In this case is 0.8, 0.85. In this case 0.85 to 1. Okay, you don't actually need to construct this range. If you are very familiar with this, then you could directly construct the VLOOKUP table. So in the first column, we're going to put up the value we will basically look up, not the value we look up, but in the first column we're going to put the first number in the range, which is 0, 0.3, 0.5, 0.8, 0.95. So as you see here, this number will represent this range, and we should choose the first number because that's how we construct VLOOKUP table. And for the next step, we're going to first insert a theory of number. You probably know that. From 1 to 5,000, this is the number of iteration I specify here. Okay, the random demand is now is not normal distributed. Instead, it's a discrete distribution. To generate that, we use the VLOOKUP function. We generate a random variable, and then we look up in this lookup table. Lock this table, and depends on whether this which interval this random would belongs to, it will return the corresponding demand, and the demand is in the second column. So let's put 2, and it's approximately match. So this is the formula to generate demand. If you double click, then we basically generate a 5,000 demand following this distribution. Given the demand, we can calculate the revenue, which is the same with the previous one. It's just the price. If you log this, multiply by the mean of your demand and order quantity, because you can only sell how much you have or how much they need your product. So this is your revenue. Remember to log the order quantity and the sales price. The purchase cost is just order quantity. Log it, multiply by your purchase cost, which is 20. And The total refund you have is the unit refund you get, log it, multiplied by the total amount of leftover, which is the order quantity minus the demand, and you have to choose positive if it's only, this is true only if these are positive, because in that case you have some leftover. Log the order quantity here, and then you get the refund. The profit is just the revenue minus the cost plus the refund. That's your profit. And you can double click to replicate into different cells, and that's your profit. You will notice that purchase cost is the same because for all the realization of demand, your purchase cost is the cost that you purchase this 200 units, so it's the same in different realization of demand, but profit may be different. That's basically represent the risk associated with this. The average profit is then given by this, and then the standard deviation of the profit is given by this. The minimum profit, the maximum profit, the channel profit is less than 200. So we count if less than 200 is 0, and I have to divide it by the total number of iteration count. Chance that profit is negative, divided by the total count. Is 0. Oh, they're both 0. As you see here, the minimum profit is 1,000. So that's the reason why we don't have profit less than 200 and 0. So probably I need to change this to say probability the profit is less than say 1,050 or 2,000. Let's just do 2,000. And this is a probability that profit is equal to the minimum profit, which is 1,000. And we have to change the formula correspondingly, 2,000 and equal to 1,000. Oh, it's the same. So the profit is, there's no way profit is larger than that. But anyway, so that's the idea. Okay, that's how we. So we basically what we did here is for each order quantity, we evaluate its performance under this random demand. And now we're ready to construct, to choose the optimal order quantity. So these are the alternative order quantity we can have, 100 to all the way to 300. And actually is the value of this order quantity is exactly the amount of demand, the possible value for the demand. And for each order quantity, we want to evaluate in these dimensions. Okay. Now we have made change to this. Let me change to this. And so to construct this data table, we need to first tell the data table what we want them to calculate by typing the things here, the minimum profit, here, maximum profit, the chance that profit is less than 2,000, chance profit equal to 1,000. And then we highlight this region, go to data, what if analysis, data table, and then we put column input cell as order quantity because the order quantity is in the column. And we want to change this cell or the quantity according to this column. Press OK, then we get a result. And we can do a conditional formatting to highlight the results that have the highest expected profit. Okay, that's 200. So if you want to maximize your expected profit, then you should order 200. And as you see here, the standard deviation of the profit is increasing. And if you order 100, then you have no standard deviation. You always earn this $2,000 because the demand will always be higher than 100. So if you order 100, you can always sell them. It's the least risky one, but you basically sacrifice some profitability because if you order 100, sometimes you have high demand but you could not satisfy it. So you're willing to take some risk and order more than 100, and that's the risk you will take, and in exchange you get this amount of profit. So that's the idea for this problem.